for the same cantilever beam, right? So now here the cantilever beam of length L, again the same length of L, carrying a point load at different location, not in the tip, remaining distance, any other distance. So that is the total length is L. The load is acting from the fixed end, from the A distance and A distance. This will be remaining L minus A we are getting. So we need to identify at any location X, what will be the slope at this C point or the C, due to the load at this C point, deflection and slope. That we need to find out. Right? So we know cantilever beam, the distance is L. The load is acting at the A distance. The remaining distance is L minus A. We are going to calculate at the X distance. And here, it may be here, it may be here, it may be here. Alright? X, X dash, X distance. Consider cross section XX as a distance X from the fixed end A. So again you take the moment, right? Moment M equal to force into distance, load into this particular distance. What distance? From where you are calculating. I am taking X and you are calculating. This is A minus X. So W into A minus X is load. M I know EI d square y by dx square is equal to minus of W A minus X. So now you start integrating. Why? Because this integrating double integral method you are solving using double integral method. Right? Integration once you will get the slope EI dy by dx equal to W. This A will come Ax minus x square by 2 plus constant will come. Now apply the fixed end case. This is a fixed end you have. If a fixed end means x equal to 0, y equal to dy by dx is 0. Apply here and you will get C1 will be. Why? Because 0, 0, 0. Then that term will come C1 equal to 0. So final equation EI equal to EI into dy by dx equal to W minus W Ax minus Ax square by 2. Now you find the slope. Why? Because we have the theta dy by dx. Slope at the C point. First we need to find out what is the slope at the C point. Right? C point x equal to what is the x value? From the fixed end it is total length is A. You have to replace the entire A value. So dy by dx equal to theta. So E dy by dx, this EI will come down. W by minus W by EI minus A. X will replacing by A and minus A square by 2. Then you will getting theta will be minus W A square by 2 EI. This is a formula for slope at the C point. Due to this load at this W at the C point, what will be the theta C? Theta C is a tangential line which is drawn from here, curvature. Right? So now as there is a no load, so now we have to say what will be happen this remaining portion. So I am applying load here. So what will happen to this C to B portion? Does it take any loads or moment, anything, sir? So there will not be any bending moment. That is why? Because in that portion there will not be any bending or any loads. Right? So definitely theta B is equal to theta B is equal to theta C. So same. Why? Because if you apply load here in a fixed one, from this point to this point only, that is A to C, this is B. A to C will get bent, but C to B will be maintained straight. Only straight line, not bending it. This is straight. This will be bent. Right? Why? Because load only acting here. Right? This will be straight. So this tangential line for the C is same for the tangential line for the B. That's why theta B equal to theta C equal to minus W A square by 2 EI. So we identified for the slope. Now you go for deflection. Again, once again you have to differentiate the equation, previous equation, which is identified the common equation of this. If you do the integration, you get EI y equal to minus W Ax square by 2 minus Ax cube by 6 plus constant C2. This you have to remember. Mathematics you have to remember. You have to find out this constant C2. Apply fixed end x equal to 0, y equal to 0 in the variable, this and this variable. You apply and you will get EI y equal to minus W Ax square by 2 minus x cube by 6. This is the equation. Now you apply at which location you have to find out the deflection. At C you have to find out what is the maximum distance from the C of the x distance. X will be A, fixed end. So you apply C equal to W, you replace x equal to A, then Ax squared by 2 divided by Ax cube by 6, then you will get W A cube by 3 EI. Slope at C point. Find out. We identified, deflection at the C point. what will be this deflection? This deflection, that is minus W A S cube by 3EI. So next we have to find out what is the deflection of this B and B dash at this tip. What will be definitely deflection will be height. From the diagram we know what is height. So from this triangle we can calculate y will be, this y, entire y will be BD plus BD B dash. So we have to find out DB plus B dash D. So we know B dash D equal to DC tan theta. From this diagram, this is a triangular. Why? Because this straight line, I already told, this is a triangular. So tan theta equal to BD divided by C dash D. That is what I am putting here. DC dash tan theta. So theta will be very small. So replacing tan theta, theta is at C point. We already identified theta at C point. That is minus WAK square by 2EI. BC equal to L minus A, the distance. So we identify B dash D equal to this value. Right? So y will be, what is the y will be total, total y, the maximum deflection at the B point is this. You have to add this value and you have to add this value. Right? So that is already you find out the y point C. This is YC. This is B dash D. You have to add this, means you are getting slope at that free end position. Minus WA cube by E3EI minus WA square 2EI into L minus A. Right?